So let's continue with the next topic of the hydrogen chapter, that is heavy water. So what is heavy water? In the previous class we have studied about water. What are the physical and chemical properties of water, which is one of the compound for hydrogen. The next compound for hydrogen is the heavy water. So chemically if we are going to see, then chemically heavy water is deuterium oxide. Okay, it is deuterium oxide. Deuterium oxide, that is D2O. Okay, it was discovered by Urey in the year 1932. Okay, and he showed that he has represented that about 1 part in 5,000 of water. Okay, water contains small proportion. Okay, water contains, the normal water contains small proportion, that is 1 part in 5,000 of D2O. That is 1 part of the 5,000 atom or the molecules of the 1 molecule of the 5,000 molecules of water will be the molecule of deuterium oxide. Also, it can be prepared by prolonged electrolysis of water. Prolonged electrolysis of water. We can prepare the D2O. Now, when water is when water is electrolyzed, when we are electrolyzing the water, when water is electrolyzed, H2 gas is liberated. H2 gas is liberated much faster than much faster than D2, and the remaining water becomes enriched in heavy water. Okay, so the main method is that uh, when we are electrolyzing water, there the H2O bond, okay, the H2O will break out rapidly, okay, as comparison to that of as compared to D2O. We will see that the H2O bond is breaking rapidly as comparison to that of D2O. And due to this reason, what will happen? Due to this reason, we will see that the H2O is breaking faster than D2O. So the water will dissociate more rapidly there. And the left out there, the slowly the concentration of D2O in the water will be increasing out there. Okay, in that particular water, the amount of D2O will increase out there, and hence the heavy water will be found out there. Okay, and hence the heavy water is been obtained out there, and nearly about 99% of pure heavy water can be found out there. For estimation, for estimately, if I am going to be make an estimation, it is estimated that it is estimated that about 29,000 liter of water must be electrolyzed, must be electrolyzed to form 1 liter of heavy water, that is deuterium oxide, that is 99% pure. Okay, so for obtaining 99% pure D2O, how much of water we will be requiring? We will be requiring 29,000 liters of water. Okay, to obtain 1 liter of D2O there, pure D2O. So like ordinary water, what is the physical properties? Like ordinary water, ordinary water, it is colorless, odorless, and tasteless liquid. And tasteless liquid. The physical constant of heavy water, the physical constants of heavy water are are generally slightly slightly higher than ordinary water. From ordinary water they are slightly higher. Okay, so it is also expected that molecular mass of D2O, molecular mass of D2O is higher than H2O. The dielectric constant, the dielectric constant for heavy water is less than normal water. Okay, it is less than normal water, and hence ionic compounds. Okay, and hence ionic compounds ionic compounds are less soluble in D2O. So now let's see the chemical reactions of heavy water. So in that, first is reaction with metals, action of D2O with metals. So generally D2O reacts with alkali and alkaline earth metals. Alkali and alkaline earth metals, slowly liberating deuterium. Slowly liberating deuterium. So here if 2Na is reacted with deuterium oxide, it will produce 2NaOD plus D2 will be released out here, which is sodium deut deuteroxide. NaOD is sodium deuteroxide. Okay. Similarly, calcium will react with deuterium oxide to form calcium deuteroxide plus deuter. Okay, so here deuterium gas or the deuterium will be released out on reaction of deuterium oxide with alkali or alkaline earth metals, but the reaction will be slow here. The releasing of the D2 will be slow here as comparison to that of the hydrogen. Action with metallic oxides. So how they react with the metallic oxides? Action with metallic oxide. So basic oxides of metals like sodium, calcium, etc. dissolves in D2O to form heavy alkalis. Okay, they form heavy alkalis. Basic oxides of metals like sodium, calcium, etc. dissolves in D2O to form heavy alkalis. Heavy alkalis. Okay, so the reaction can be Na2O plus D2O will give 2NaOD, sodium tetroxide. CaO plus D2O will give calcium deuteroxide. Calcium deuteroxide. Calcium deuteroxide. Okay, so this is the reaction of metal oxides with the deuteroxide. Okay, they are producing their heavy alkalis. Next, action with non-metallic oxide. Reaction of deuteroxide with non-metallic oxide. Non-metallic oxides. Non-metallic oxides such as phosphorus pentoxide, sulfur trioxide, etc. readily dissolves in D2O, forming their corresponding deuteroacids, forming their corresponding deuteroacids. So here P2O5 plus D2O will give 2D3 PO4. Deuterophosphoric acid. Deuterophosphoric acid. SO3 plus D2O will give deuterosulfuric acid. Deuterosulfuric acid. Okay. So these are the reaction of non-metallic oxides with the deuteroxide. Okay. Here deuterium oxide is reacting with the non-metallic oxides to form their respective deuteroacids. Okay. Next, reaction of deuteroxide with the carbides and nitrides. reaction of D2O with carbides, nitrites and phosphides, also with arsenides. Arsenides. Okay, so here calcium carbide when reacted with D2O will produce heavy calcium oxide, hydroxide. Okay, calcium deuteroxide plus C2D2, that is deuteroacetylene. When aluminium carbide reacts with deuterium oxide, it will form aluminium deuteroxide plus 3CD4, that is deuteromethane. Next, magnesium nitride reacts with deuterium oxide to form magnesium deuteroxide plus deuteroammonia. When calcium phosphide reacts with deuteroxide, it will form calcium deuteroxide and deuterophosphine. Deuterophosphine. Okay, so this is the different reactions of deuterium oxide with the carbides, phosphides, nitrites and the arsenides. Next, electrolysis of deuteroxide. Electrolysis. So heavy water on electrolysis, heavy water decomposes to give deuterium and oxygen, which are liberated at cathode and anode. Cathode and anode respectively. Okay, so here 2D2O will give 2D2 plus O2. Okay, so deuterium will be released out here on electrolysis of deuterium oxide. Next is the exchange reactions for deuterium oxide. Okay, so when compounds containing hydrogen are treated with deuterium oxide, hydrogen undergoes exchange for deuterium, and the reactions are NaOH plus D2O. Here deuterium and hydrogen will be replaced or exchanged with each other to form NaOD plus HOD. Okay. Next, NH4Cl reacted with D2O will form ND4Cl plus HOD. Okay. Similarly, HCl reacted with D2O, it will form DCl, that is deuterochloride with HOD. Okay. Similarly, when chloroform reacted with heavy water, it will form CDCl3, deuterochloroform plus HOD. Next is the formation of deuterates. As hydrates are found, so similarly deuterates are also formed. Formation of deuterates. So like ordinary water, heavy water heavy water combines with many compounds as heavy water of crystallization. These heavy water hydrates are also called deuterates. Okay, they are termed as deuterates also. They are also termed as deuterates. For example, CuSO4.D2O. How many? 5D2O. MgSO4.7D2O. NiCl2.6D2O. COCl2.6D2O, etc. The biological properties. Okay, so heavy water is injurious to plants, animals, and human beings. Okay, it is harmful for plant, animals, and human beings because it slow down the rate of reaction occurring in them. Okay, so hence we can say that heavy water does not support life so well as done by ordinary water. Now Let's see what are the uses of heavy water. So first, heavy water is used in nuclear reactors as a moderator because it slows down the fast moving neutrons, and therefore it helps in controlling the nuclear fission reaction. Okay. Number two, heavy water is also being used as a tracer. Okay. It is used as a tracer compound to study mechanism of various chemical reactions. Okay, in order to study the mechanisms of chemical reaction, heavy water is used as tracer compound. Okay. Third, heavy water is used as one of the reference in nuclear magnetic resonance spectroscopy. Okay. Also for preparing heavy hydrogen or deuterium can be used by heavy water for electrolysis process. Okay, by electrolysis we can prepare D2 there. Next, let's talk about hydrogen as a fuel. Okay, how hydrogen can be used as a fuel and what is the use there. So hydrogen, liquid hydrogen, which can be used as a fuel. So fuel burns to release large quantity of energy. Okay, fuels burns to release large quantities of energy. Okay, so the combustion of fuels such as dihydrogen, methane, liquefied petroleum gas, that is LPG, and gasoline, okay, also called as octane, as compared in the terms of the small amount in moles, mass and volume. Okay, we can compare their energy releasing. Okay, so here energy released on combustion, which is in kilojoules. Next, dihydrogen's energy release, which is in its gaseous state, dihydrogen in its liquid state, LPG, methane gas, and octane in its liquid state. So here, per mole, the energy release for dihydrogen will be 286 kilojoule per mole. Okay. For liquid, it will be 285 kilojoule per mole. For LPG, it is 2220 kilojoules per mole. For CH4, methane, it is 880 kilojoules per mole. For octane, it is 5511 kilojoule per mole. Similarly, per grams, it is 143, 142, 50, 53, 47. But in per liters, 12 kilojoule per mole, 9968 kilojoule per mole, 25,590 kilojoules per mole, 35 kilojoule per mole, and 34,005 kilojoule per mole. So this is the amount of energy which is released by the different fuels which we are using in the environment or in the daily life of ours. So here, it is clear that on mass to mass basis, okay, it is clear here, that on mass to mass, okay, on mass to mass basis, dihydrogen can release more energy than gasoline also. Okay, it can release more energy, while the pollutants on H2 burning is less than petrol. Okay, the only pollutant will be there, the only pollutant which will be the oxide of dinitrogen, okay, due to the presence of impurity. Okay, the only released pollutant released on combustion of H2 is N2, NXO. Okay, is NXO or NOx. Okay, due to impurities of nitrogen in it. Impurities of nitrogen in it. Okay. However, this can also be reduced by injecting small amount of water into the cylinder to the lower temperature so that the reaction between dinitrogen and dioxygen may not occur. Liquid hydrogen, okay, liquid hydrogen is one of the important fuel for rocket. Liquid hydrogen is used as an important rocket fuel. Okay, it is used as an important rocket fuel. Okay, due to its high mass to mass basis ratio for producing energy, it is being used as an important rocket fuel. Let's see what are the advantages of dihydrogen as a fuel. So advantages, first, it releases greater energy per unit weight of the fuel of the fuel. The only product of combustion here is water. Combustion is water. There is no emission of there is no emission of pollutants. Fourth, IC engines, that is internal combustion engines, can easily be modified can easily be modified for using hydrogen as a fuel. As a fuel. Fuel cell. Fuel cell for generation of electric power with conversion efficiency of 75 to 80% have been successfully operated commercially. Okay, it has been successfully operated commercially. So why we are not using hydrogen fuel regularly? What are the problems or limitations of hydrogen fuel? Hydrogen. Number one, hydrogen is highly combustible. Highly combustible, combustible and is difficult to handle safely. And is difficult to handle safely. Number two, to transport hydrogen it is hard. To transport hydrogen fuel is difficult. So these are some of the limitations due to which we are not using hydrogen on a very large scale. Hydrogen fuel on a very large scale. It is been used just as a rocket fuel nowadays. Okay, but to use it in a very uh, common manner in our daily life, it is very hard till now. Okay, still it is very dangerous for us. But similarly, the alternative, as humans are discovering, as humans are looking for an alternative source of energy, so the hydrogen can be a pollution-free alternative source of energy. But for that, still huge amount of research work and innovation work is required out there. So still the changes is going on, and after I think, and it has been expected that in the near years we will be able to use hydrogen fuel frequently in every space. Okay, frequently in every space. So for today's class, I am ending the class here only. We will continue with the next chapter, that is the redox reaction, in the next class. So thank you.